Hello, sorry. Hello and welcome to our science video on calorimetry. I hope you can understand me through my voice issues. What we've got here is we've got something called a hot plate, which you may not have used yet at Grayland. This is just a way of getting a beaker, boiling some water. We don't care about monitoring the temperature of the beaker so much, and it's also a lot more stable than a Bunsen burner for this experiment. So we've also got a graduated cylinder with a measured amount of water. We've got a secondary beaker that we're going to put our metal into, and we've got a few different metals that we're going to hopefully figure out the heat capacity of, which is measuring how much heat or how much energy they can carry. So we've got some water in there. It doesn't matter how much you've got in there. This is your hot water bath, kind of like your ice water bath was in the lab where we were dunking the soda cans in there. So you want to very carefully put your cube here. You don't want to drop it, because I have seen students break beakers of boiling water before, so carefully set it in there and let it go at the bottom. What you'll notice that it stopped boiling as vigorously for a second, and that's because some of the energy went into that cube. So right now, some of the energy from the water is entering the cube, making the cube's temperature increase. What our assumption is that over time, the water and the cube reach the exact same temperature. So my assumption is that after about, we'll say, a minute and a half or so of sitting in the water here, the cube should have reached the same temperature. So while we're waiting for that to happen, I'm going to measure the temperature of the water. This is one of your first important measurements and assumptions. You're assuming that temperature of this water equals the starting or initial temperature of the cube. So right now, I'm measuring this water as 94.9, 95.0. It's kind of wavering in between those two. So I would say our cube right now is at 95 degrees. What we're going to do is we're going to add it to our calorimeter. It's a big fancy word for a thing that measures the energy. It's pretty low tech, actually. We're going to use 2 coffee cups. They're nested. The reason for that is it actually traps a little bit of air in between those 2 coffee cups, which actually acts as extra insulation along with the foam. I've got a little cardboard here that just acts as a cover. Notice I've got a hole in there, which we're going to put our thermometer in. So I'm going to take my thermometer out of there. A good thing to do would actually be to put this, run under some water there quick to cool it down. Now, I told you that the amount of water in there didn't matter because it's just serving to heat up the cube. The water in here, it doesn't matter how much you actually use, so long as you measure it very, very accurately. I'm going to pour this water into my calorimeter, and that was exactly 49 milliliters. I was 1 milliliter short, so I wrote down 49, not 50. It matters because if you've got less water, it's going to heat up more. If you've got more water, it's going to heat up less. It matters for the calculations. So now I want to take the temperature of this water. It starts at, right now it is at 23.0 degrees. So that would be my initial water temperature. So now what we're going to do, I'm going to put this in here. Once again, this is supposed to trap as much heat as possible in there. You want to create a closed system so all of the heat is going directly from the cube being lost into the water. Another thing you want to be careful with is not to jab a hole in the bottom of your coffee cup. I've seen that happen as well, so be careful about that. Okay, so here goes nothing. We'll take this out. This is at 95 degrees right now. As fast as possible, with as little water dripping on there as possible, we'll drop it in here and put that in there and start watching what's happening to the energy. So keep this as firmly attached as you can, and ideally you want to be able to kind of stir that water, mix it up a little bit so it kind of evenly distributes. I don't know if you can see this in the video, the temperature is going up right now. What you're going to wait for is you're going to wait for that temperature of the water to stabilize. Mine is not quite stabilized yet. Right? It's at 29.4 degrees, 29.7, 29.9. If you want, you can even shake it around a little bit like that just to get that water all evenly mixed. Right now, looks like it's reached a max of about 30.0 degrees. So I'd write that down as my final temperature. So what we can do now is we can figure out, okay, well, it made 49 milliliters of water go up 7 degrees, and if you measure the mass of this block that was in here, you can grab this now, if you measure the mass of the block that was in here, you can say, okay, so 7 degrees of change in water, measure the mass of this, figure out how much energy left this block and entered into that water. So you're going to have to work backwards a little bit to figure out the actual math of how much energy was in here. I'm going to run some of those calculations probably excuse me, in a separate video, but this is what I want you to see. You can repeat this exact same procedure with different metals, aluminum, copper, lead. The big key here is you'd probably want to replace this water with some cooler water again. Re-measure the temperature of this water. When you put your cube in here, make sure to monitor that temperature because it might be slightly different. And that's what you are going to be doing on Friday. So have a great day. I will see you later.